Hey everyone, today we are going to keep talking about transformations. We did translations last time. Today we're focusing on reflections. And then I made this chart to kind of summarize what we've done so far. Out of the 4 transformations that I've written in pink, 3 of them are isometries. That would be translations, reflections, and rotations. Those have same shape, same size. Exactly the same. They are congruent. The non-isometries is just a dilation. So that means they're similar but not congruent. Same shape but different sizes. There's been a stretch or a shrink. We learned the rule for translations the other day, and I wrote that in purple. So for the x-coordinate, you would add or subtract some mystery number. And for the y-coordinate, you would add or subtract some mystery number. That's what causes a shape to slide across the graph. Today we're going to be talking about reflections. Reflections are a flip. And I'm going to be going over the rules for that as well. So I have them written in purple, but I want to show you how they work, and then I'll come back to what I have in purple up here. So on this page, they're actually asking you to apply the rules for reflections without any graph. Of course, you always can do a graph, but if you can do it without a graph, it's a time saver. I'm going to demonstrate one from each section with the graph to show you the rule, and then we're going to try without the graph. So in the first section, we want to reflect the point in the x-axis. That means the x-axis is our mirror. So I'm going to highlight the x-axis. We're going to be flipping over that. So let's see. They want us to move in number 1 to 5. So I'm going to graph 2, 1, 2, 3, 4, 5. So this is 1, and I'm going to change it to 1 prime by reflecting it over the x-axis. When you reflect over a mirror, you want it to be the same number of spaces away from the mirror on both sides. So this is going to be 5 up, and I want to go 5 down. So 1, 2, that's 1, 2. Oh, it's hard to do it like that. I'm going to plot it first, and then I'll show it to you because the line keeps going straight. So 1, 2, 3, 4, 5. So that's going to be point 1 prime. And I've gone 5 down. I've reflected it over the x-axis. So let's see what happened to the points. 1, the original point, is 2, 5. 1 prime, the new point, still is at 2, but it's at -5 now instead of +5. So when I reflected over the x-axis, what happened was that the x-coordinate stayed exactly the same. So if I'm reflecting over the x-coordinate is protected, but the y-coordinate became the opposite. X stayed the same, y went from 5 to -5. So the rule for reflecting over an x-axis is that you keep the x-coordinate the same and you take the opposite of the y-coordinate. Using that rule, try number 2. So for number 2, we want to keep the x-coordinate the same. That's -3. And we want to take the opposite of the y-coordinate. That's -7. So the answer choice that matches that would be A. Of course, you can graph it too, but we don't want to have to make a graph every time. And I also realized I forgot to put the answer for number 1. We said that the new point was 2, -5. So that would be that choice. 3 and 4 would work the same way. So the rule for the x-axis is you keep the x the same, take the opposite of y. Let's look at the second section now. So that one reflecting over the y-axis. I'm sure you can predict what the rule is going to be, but let's take a look. For number 5, they are asking us to reflect the point 7, -6. So 5 prime has to be my reflection of that. And since we're reflecting over the y-axis, that means here is my new mirror. So let's take a look. 7, -6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So here's point 5. And I need to reflect it over the mirror. So it's 7 this way, because I went 7 to the right. And now I need to go 7 to the left. So 1, 2, 3, 4, 5, 6, 7. So this is 5 prime. So both of my points are 7 away from the mirror. My new coordinates would be -7, and the -6 stays the same. So what's happened here is that x became the opposite and y stayed the same. So -x, y would be the rule. -x, y. So if you look at the two rules together, whatever axis you're flipping over, that coordinate gets locked in. When you're reflecting over the x-axis, x is locked in. When you're reflecting over the y-axis, y is locked in. The other point becomes the opposite. So we said that the answer to that was -7, -6. That would be this choice right there. And the rule worked. 7 became -7, and -6 was locked in. Try number 6 now. All right, hopefully you've done that one. So x has to become the opposite. That's -9 instead of 9. Y is locked in. So -9, 5 should be the answer, which is this one. And you can do a graph to check it. So let's look at the rule that I wrote up here. So all I've done is I've written exactly what I just showed you. In the reflections box in purple, you could see for x-axis, you keep the x the same, take opposite of y. For y-axis, you take the opposite of x, but y stays the same. So it matches. If it's the x-axis, well, let me highlight it for some reason. I'm trying to highlight the letter x. If it's the x-axis, x is locked in. If it's the y-axis, y is locked in. The other one becomes the opposite. You can always graph it as a backup, but it's easier not to. So I hope you try to use the rules. You still will have to finish up this page, but that's how this page is done. On this page, it says some of the questions will be about tell whether or not it is a reflection. So you're basically just saying, did it go over a mirror or not? And then some of the questions ask you to actually do the reflection. So use those rules we just did. Back to this, you could take a screenshot of these rules and put the screenshot on the next page so you could reference it while you work. So see if you could use the rules for all of this down here. All right, and then the last thing I want to show you is more of an extension, but I like to show it because I think it's interesting. If you think this will confuse you, don't worry about it. But I think a lot of you guys will benefit from just getting to see it one time. You don't have to do it on your own. So I'm looking at number 6 over here. And what's different about this one is it says to reflect across y equals -2. So instead of reflecting across the x-axis or the y-axis, we're reflecting over y equals -2. So I'm going to highlight that as my mirror. If y is -2, that means it goes across because y for each of those points is -2. The x value of each of those points changes, but the y value is always -2. I'm going to plot my original points. So h is -1, -5. So -1, 1, 2, 3, 4, 5. Here's h. M is -1, -4. Very close to h. So there's m. B is 1, -2. Right on the line. And C is 3, -3. So here is my original figure, my pre-image. Nothing's happened to it yet. So, as you guys can probably predict, if you reflect it across this point, you ignore the x and y axis, and the green line is your new mirror. So if I look at M, I'm going to start with M. M is 2 away from the line, so it needs to be 2 away above the line as well. So I'm going to take M right here. This is M prime now. They're both the same distance from the mirror. I need to erase the blue lines, otherwise it's going to get crowded, but you can imagine that they're still there. H is 3 away from the mirror, so it needs to be 3 away going that way from the mirror. So here's H prime. So it's flipped over the mirror. Let's see. B is on the line itself. It's 0 away. So B prime is going to be at the exact same spot. C is 1 away, so it needs to be 1 away again. So that's C prime. I lost my line. Let's see. There we go. So my image would be this. It's really the exact same thing. It's just not an axis. It's on this green line instead. So that's how to reflect it across a different point. There's a couple others on this page. If you want to try them, 2 and 3 that are not over the axis. I think that they're interesting to try. I think they're worth trying, but that's more of an extension question. All right.